Okay, today's topic are the 4 theorems of parallelograms. You're going to need a sheet of paper and a pencil so that you can copy down some definitions, as well as create a table that you're going to write down the theorem and draw a picture. So make sure that you have some notes ready to go. Okay, let's talk about our vocabulary that you're going to need to know today. The first term is parallelogram. The second term is supplementary. The third term is congruent, and the fourth term is bisect. If you are even slightly unfamiliar with any one of these 4 terms, I want you to write them all down. Okay, if you know them by heart, then don't worry about it. But if you're even not really sure, write them down. So the first definition is parallelogram. And a parallelogram is a quadrilateral with 2 pairs of opposite sides parallel. Supplementary is a term that we've gone over already as well, and it is angles whose sum is 180 degrees. Congruent is a third term that we've heard a lot of so far, and congruent is same shape and size or equal. And then the last term, bisect. Bisect is a verb, and bisect means to cut in half. You can cut in half a line segment or an angle. Okay, so you bisect an angle or bisect a line segment. Okay, if you're not sure about those, pause the computer right now and make sure that you get those vocabulary terms down. Okay? All right, now that we've copied those terms down, let's go to the next slide, and this is the table that we're going to draw. I'm going to recommend that you draw it after you see Theorem 1 and Theorem 2 as well as both pictures, because you don't know how much space you need. So wait until Theorem 1 and Theorem 2 are done, and then you can create the table. So Theorem 1 states, if a quadrilateral is a parallelogram, then opposite sides are congruent. Okay? Then opposite sides are congruent. There's that term, congruent. Congruent means equal or the same. So a quadrilateral, 4-sided shape, is a parallelogram. Opposite sides are congruent. So let's look at the picture. So in this picture, we have parallelogram A, B, C, D. And what these markings are telling us is that line segment AB is congruent to line segment DC, and line segment AD, which has 2 markings, is congruent to line segment BC. Okay? The way that you would write this is as follows. Line segment AB is congruent to line segment CD, and line segment AD is congruent to line segment BC. Okay? Let's move on to Theorem 2. Theorem 2 states, if a quadrilateral is a parallelogram, then opposite angles are congruent. Again, there's that term, opposite angles are congruent. Congruent is the term. Looks very similar to Theorem 1. Theorem 1 says opposite sides are congruent. Theorem 2 says opposite angles are congruent. So let's think about that for a second. Let's look at the picture. So we have angle A and angle C both have the variable x, degrees, meaning that they're going to be the same measurement. And angle D and angle C, angle D and angle B both have the same letter, the variable of y, meaning they would have the same measurement. Okay, if you wanted to draw on this and you wanted to have your markings would look something like this. You know, you could have one marking here, one marking there. You know, maybe we'll change colors, and we'll go with a gray, and we'll say that B would have 2 markings, and D would have 2 markings. Okay? And then we would say that angle A and angle C are congruent, and angle B and angle D are congruent. Okay? Any questions on those? Okay, why don't you pause your computer right now and copy down this chart, making sure that you write down everything as you see it, okay, with the appropriate markings and the appropriate letters and statements, congruent statements on the left side. I'll give you time right now. Okay, now that you have those Theorem 1 and Theorem 2 copied, let's go to Theorem 3 and Theorem 4. Theorem 3 states if a quadrilateral is a parallelogram, then consecutive interior angles are supplementary. Oh, there's that vocabulary word, supplementary. Supplementary means angles that add up to 180 degrees. Okay, consecutive interior angles. We talked about those when we were dealing with parallel lines and a transversal. So let's see what we got. So if we have quadrilateral ABCD, what that means is that our angle X and our angle Y are going to add together to equal 180 degrees. And I'm going to give you 4 examples here. The first example is angle A plus angle B equals 180. The second example, angle B plus angle C is going to equal 180. The third example, angle C plus angle D equals 180. And the fourth example, angle D plus angle A would equal 180. So as long as the angles are next to each other, it doesn't matter what order they're in, you're going to add them together to equal 180. And then the last one, Theorem 4, states if a quadrilateral is a parallelogram, then diagonals bisect each other. Diagonals, okay? So we got to deal with diagonals right now. So if I'm drawing a diagonal line, it's going to be from D to B, and A to C. And where the two diagonals intersect, I'm going to put the letter M there for midpoint. Because when you bisect something, you cut it in half. So that's going to be our midpoint. Now, how can we show that the M is the midpoint of AC? Well, we draw 2 marks like that. And then what would the congruent statement that goes along with that? The congruent statement is going to say line segment AM would be congruent to line segment CM. Okay? And we have one more diagonal. So, diagonal DB has a midpoint of M as well because the diagonals bisect each other. So we're going to show that these are congruent to each other. So DM is congruent to BM. Okay? Does anybody have any, if you have any questions about that, please refer back to the video, watch it again. You should probably watch this video probably 10 times before you actually learn everything. And then ask your teacher. Okay? Have a great day.